The third question that we have, we've been asked, or rather given, that a plane is parallel to two lines whose direction ratios are given as 1, 0, -1 and minus, 1, 0, and it is also given that the plane contains the point 1, 1, 1, and it is given that this plane cuts the coordinate axis at the points A, B, C. We need to find out the volume of the tetrahedron OABC which is formed. Now, whenever it is given that it cuts the coordinate axis at A, B, C, it is assumed that A point is the point where it cuts the x-axis, this is for the y-axis, and this is for the z-axis. Now let us start with the question. Any plane containing a point x1, y1, z1, the equation of this plane can be written as A times x minus x1 plus B times y minus y1 plus z times plus c times z minus z1 is equal to 0. This is because when we put over here this point in this equation, we get 0 equal to 0, which that is this point satisfies this equation, therefore this point lies on this plane. Therefore we write the equation for our above plane similarly to get the equation of the plane as A times x minus 1 plus B times y minus 1 plus c times z minus 1 equal to 0. Now it is given that this plane is parallel to the two lines whose direction ratios are 1, 0, -1 and -1, 1, 0. So let us consider this line first. The direction ratios of the line are 1, 0, -1. Therefore the direction in which the line is 1 into I cap plus 0 into j cap minus k cap. Similarly, the direction in which this line is minus I cap plus j cap. Therefore, since this plane is parallel to both these lines, the normal to this plane will be perpendicular to both these lines. Now, we know that, or rather you should know that, for a plane AX plus BY plus CZ equal to 0 or CZ is equal to D, the normal is given by AI cap plus BJ cap plus CK cap. That is, you take the coefficients of X, Y and Z and write it here to get the normal. Now, therefore we know that the normal for this plane will be AI cap plus BJ cap plus CK cap. Now, since this is perpendicular to this and this normal is also perpendicular to this, therefore we can write the dot product of these two to be equal to 0. That is A minus C equal to 0. From these two we get minus A plus B equal to 0. From these two we get A is equal to B equal to C. Now since all these three are equal, they can be removed. They can all be removed from here to get x minus 1 plus y minus 1 plus z minus 1 equal to 0. That is x plus y plus z is equal to 3. Therefore we get the equation of our plane. Now we need to find out the points where it cuts the coordinate axis, that is A, B and C. Now remember this trick, that write this equation as x upon 3 plus y upon 3 plus z upon 3 equal to 1. Whenever you write the equation in the format something x upon a plus y upon b plus z upon c equal to 1, then it cuts the x axis at A, it cuts the y axis at the point B, and at a distance b, that is, it cuts the x axis at A, 0, 0. It will cut the y axis at 0, b, 0, and the z axis at 0, 0, c. So by applying the same logic over here, we get the point A as 3, 0, 0, the point B as 0, 3, 0, and the point C as 0, 0, 3. Now let us plot these points on the three-dimensional plane. It always gives you a better idea of where the points are located. This is the Z, this is the X, and this is the Y axis. Now point A is 3, 0, 0. This is point O, that is origin. This is A. The B point is here, that is 0, 3, 0. The C point is here, that is 0, 0, 3. Now these 4 points, to get a tetrahedron, now we need to find out the volume of this tetrahedron OABC. Now an important thing to note here is that this is point C, that this is not a regular tetrahedron, because though these three sides are equal, this side is not equal to this side. This side, the length of this side is 3, while the length of this side BC is 3 root 2. Therefore this is not a regular tetrahedron. So for finding out the volume of this tetrahedron, we can write this as 1/3 into area of base into height. You can remember this formula also. Now you can imagine this plane ABC form the base of the tetrahedron, and this point O is inside the plane of the board, and that will form the topmost point of the tetrahedron. It will become something like this. This is the point O. These three are the points A, B and C. Now ABC is the base, therefore we first need to find out the area of the base. Now ABC forms a equilateral triangle. This is actually like this. Now ABC forms an equilateral triangle, therefore the area can be written to be equal to root 3 by 4 into side square. Now the side is equal to 3 root 2, therefore 3 root 2 whole square. This is the area of the base. We write down this over here to get 1 by 3 into 18 into root 3 upon 4. Now in this diagram we need to find out the position of centroid for an equilateral triangle. It can be easily done. This angle will be equal to 30 degree. This is equal to S by 2. Therefore the distance of the centroid from one of the vertices will be equal to S by 2 divided by cos 30 degree. That is S by 2 cos 30 degree. That is equal to S by 2 into root 3 by 2. That is equal to S upon root 3. We know that the side of this equilateral triangle is 3 into root 2. Therefore this becomes equal to 3 root 2 upon root 3, that is equal to root 6. Now this length, that is, let this point be P, PB becomes equal to root 6, and we already know OB is equal to 3 as can be seen. Therefore we can write OP is equal to root over 3 square, that is 9 minus root 6 whole square. By Pythagoras theorem this comes out to be equal to root 3. Therefore we know the height to be equal to root 3. This cancels to give us the answer 9 by 2, which is our final answer for the volume of the tetrahedron. You could have done it easily also. We know that the equation of this plane ABC is x plus y plus z is equal to 3, and this point O is the origin, that is O is 0, 0, 0. We need to find out the perpendicular distance of this point from this plane, which can be easily found out by putting in the value over here, that is 0 plus 0 plus 0 minus 3 upon root over coefficient of x whole square plus coefficient of y whole square plus coefficient of z whole square. This comes out to be equal to 3 upon root 3, that is equal to root 3, and this is the same answer that we got by this method. On putting this root 3 over here, we will get the height. So we can find out the perpendicular distance of any point from a plane by this method. Now there is another way to find out the volume of a tetrahedron. Now since when this is the base, this is a tetrahedron, it need not be regular, and the side length of this is A, this is B, or rather OA is A, OA is equal to A, OB is equal to B, and OC is equal to C, then the volume can be written to be equal to 1 by 6 times ABC. So by using this formula also, we get 1 by 6 into 3 into 3 into 3, and we get the answer as 9 upon 2 cubic units, which is the same as the answer we got over here. Therefore our final answer for the volume of the tetrahedron OABC is 9 by 2 cubic units.